Hey folks, in this video we're looking at Half-Life and all sorts of stuff about Half-Life. So we got some objectives, yeah, and those are to be able to explain what Half-Life is, at least in the context of nuclear chemistry, also to explain how Half-Life, the half-life of an isotope relates to the stability of the isotope. And I also want you to be able to perform calculations using Half-Life and waffles? I don't know, maybe. Let's get going. So, Half-Life. Half-life is the amount of time it takes for half of the atoms in a sample to decay. It looks a little weird. We'll see an example to help ground that. So the symbol we use for half-life is this cool T1/2 dude, because it's time, or half, related to time. And yeah, we measured in units of time. These can range from less than a second to way more than trillions of years. So half-lives are very variable. Every different isotope has its own unique half-life. Well, it's an indicator of stability. If something has a very long half-life and takes trillions of years to decay, it's pretty stable. Compared to something that decomposes in less than a second, that's not very stable. It falls apart very quickly, like unstable things tend to do. So let's look at an example to help this make sense. We have 4 radioactive atoms, and we're going to say the half-life of this isotope is 10 minutes. Here are my 4 radioactive atoms. Well, after 10 minutes, the half-life, I'm going to have half of these dudes decaying. That means half of my radioactive isotopes have decayed into something else. Well, another 10 minutes later, half of my radioactive isotopes are going to decay. So I had 2, now I'm only going to have 1 left. And I guess we could say after another 10 minutes, this last one is probably going to decompose. So, don't quote me on that. So, that's generally how half-life works. It's usually just dividing the amount of stuff you have by 2, cutting it in half. And so every 10 minutes, we can see half of the radioactive atoms decay. And so the decay products also might be radioactive and decay again. We're not going to worry about that. Generally, our decay products are going to be radioactive. But again, we're not going to worry about how they will decay on their own. Half-life, math-life, let's learn how we can solve for the final mass of a sample. Most of the half-life problems we'll do involve multiplying by 2 or dividing a number into a bunch. We'll see. And so this is because every time a half-life passes, the amount of atoms in a sample are halved, or divided by 2. So first example, we got 78 grams of a radioactive isotope, which is a half-life of 10 seconds. How many grams of the isotope will be left after 40 seconds? Why don't you pause the video and see if you can try this on your own? Sick! You paused that video and you tried it out. Let's do this together. So the first thing I'm going to do with a half-life problem is look at, there are 4 crucial things that I want to think about. I want to know, do I know the starting mass? In this case, I do. I have 78 grams to start with. Do I know the final mass? No. I'm being asked, in this case, how many grams are going to be left at the end of the time that we're looking at. Do I know the half-life? Yes, I do. It's 10 seconds. And do I know the total? No. Do I know the total time that we're talking about inside this problem? Here, we're talking about 40 seconds total. So I do know that. Great. Half-life problem, we're usually going to solve for one of these 4 pups. In this case, we're looking for the ending mass. So I'm going to first say to myself, well, over these 40 seconds, how many times does the half-life go by? If I know the full time and the half-life, I'm going to generally start by asking myself, how many half-lives went by? Well, the number of half-lives is going to be our total time divided by T1/2, the half-life. So 40 seconds divided by 10 seconds gives me 4. I know that 4 half-lives go by in 40 seconds. That means I'm going to cut this number 78 in half 4 times. So we'll start with my 78. 1 half-life, or 10 seconds goes by. And now I've got 39 grams. Another 10 seconds goes by. Well, now I'll have 19.25 grams. Another 10 seconds goes by. Of 9.75 grams. Is that enough? Well, let's see. That's 1, 2, 3 half-lives. I've cut it in half 3 times. I got to do it 1 more. And that'll bring me to 4.875 grams, my ending mass. And we can see this was 10 seconds, 20 seconds, 30 seconds, 40 seconds total when I add up all of the time. Sweet. Let's look at another problem. If I wanted to solve for the initial mass, like in this problem, why don't you pause the video and see if you can figure out what to do here? Cool. Well, I'm going to do my inventory. I don't know the starting mass. I know my ending mass. It's 10 grams. I know what the half-life is. And I know the total time. So since I know half-life and total time, first thing I'm going to do is figure out how many half-lives went by. I'll do my total time divided by the half-life. Say, all right, 5 half-lives are going to go by in 4.19 seconds. We'll say to myself, okay, I want to know how much I had to start. If I'm ending with 10 grams, one half-life before this, or 0.838 seconds before I had 10 grams, I would have had 20 grams. That same half-life before, I would have now had 40 grams. I can go backwards another half-life. Say, oh, well, I have 80 grams. I have 160 grams. Let's see, that's 1, 2, 3, 4. I need to go back 5 half-lives. I'll double 160, get to 320 grams. So here, I just took the ending amount, and I multiplied it by 2 5 different times, because 5 half-lives went by. So there I have my final mass, or I'm sorry, my starting mass of 320 grams. Sweet beans. Waffles. Check out those waffles. I'd eat those. I'd eat those. Whoa. 34 ways to eat waffles for every meal. I'm into that. What? Lettuce on a waffle? I say no to this. No. Anyway, let's look at more math. Half-life, life, all night. So here we have a problem where we want to have to figure out what the total time taking place over this problem is. So we know the starting mass. That's this 0.0056 grams. We know the ending mass, that's this 0.0007 grams. Hold our breath and exhale this amount. We know the half-life, that's given to us, it's 55.6 seconds. We don't know what the total time is, how long we're looking at this radon 220 reacting, or rather decaying. So since I can't go ahead and figure out how many half-lives occurred right away, what I'm going to do is look at my ending mass and starting mass, and say if I started with 56 grams, well, when I cut that in half, I should have 28. When I cut that in half, I should have 14. When I cut that in half, I get this 0.7 grams. And that's what I want to end with. And each time I've told myself, well, one half-life went by, or 55.6 seconds every time I cut this in half. So now I see, all right, I've got 55.6 seconds 3 times. So the total time will be 3 times 55.6 seconds, or 166.8 seconds, a little bit shy of 3 minutes, which is a pretty long time to hold your breath. Good job. Good job. Let's look at one more problem. Here we've got solving for half-life. So why don't you read over this problem, pause it, and give it a shot. Sweet. You give it a try. Hopefully you came up with what I'm about to do. Let's go through it. So I know the starting mass. It's 128 grams. I know it decays to 16 grams. That's my ending mass. I don't know the half-life. They're pretty clearly asking what is the half-life of this isotope. And I know the total time. It was 1,277 years. So similar to that last problem, since I already know the starting and ending masses, I'm just going to figure out how many half-lives took place to get from here to here. So I'll do 128. I'll divide that by 2. That's 1 half-life. I'll divide that 64 by 2. That's 1 more half-life. I'll divide it by 32 by 2. It's another half-life. Okay, cool. It only took 3 halvings, or 3 half-lives, to get from 128 to 16. So I know that in that 1,277 years, there were 3 half-lives. I could say 3 half-lives equals 1,277 years. And I can divide both sides by 3 to get half-life equals 425.7 years. Hot sauce. Sweet. Well, that is the end of this video. I hope you feel like you have a better understanding of what half-life is, how we can gain information from it, and how we can use it to do sweet, sweet maths. Ta-ta, and have a great rest of your life.